do a few more with rational function here. So find the domain. Let's say part A, f of x is equal to x minus 2 over 3x squared plus 8x plus 5. And let's see here, we have a fraction, so we have a denominator, so we cannot have that denominator, 3x squared plus 8x plus 5, cannot have it be equal to 0. Now this factoring is a little bit more complicated than the previous one. The previous one didn't have a coefficient on the x squared, so in this case we have a 3 on the x squared. That makes it a little bit more complicated. In this case we need to look at, okay, we have a 3 and a 5 here, so we need factors of 3 times 5 is equal to 15 that add up to 8 there. So factors of 15, we could do 1 and 15, we could do -1 and -15, we could do 3 and 5, or we could do -3 and -5. Now the only pair there that adds up to positive 8 is 3 and 5. So I'm going to go ahead and make use of those. So I'll leave my 3x squared alone. I'll leave my plus 5 not equal to 0 alone. But that 8x, I'm going to split it up as 3x plus 5x, because I just figured out 3 and 5 are the factors that multiply to 15 and add up to positive 8. I know people have different ways of doing this, diamonds and boxes and all these different things. Whatever is comfortable for you, please make use of that method. Here, this is how I learned it originally. I'm going to go ahead and group these terms now. Group the first two, group the last two. From the first two, I can pull out a 3x. That'll leave me with an x plus 1. From the second group, I can pull out a 5. That'll leave me with an x plus 1. Now, if your two inside groups there, if they don't have the exact same thing there, something went wrong. Not sure what it was, but something for sure went wrong if you don't have the same thing on these inside parts here, x plus 1, x plus 1. Because on my next step, I need to factor that out. I'm going to factor out x plus 1. It'll leave me left over. I have a 3x, so 3x, and a plus 5, plus 5. And now that it's factored, I can go ahead and think about finishing up this problem. So x plus 1 cannot be equal to 0, and 3x plus 5 cannot be equal to 0. So let's see here, subtract 1 from both sides, x cannot equal -1. Subtract 5 from both sides, and divide by 3, so x cannot be -5/3. And I'll go ahead and do my number line like I have been. I have a -5/3 and a -1 here, not equal to's. So set notation answer, x such that x is not equal to -5/3 and -1. And then interval notation answer, -infinity to -5/3. And then, union, -5/3 to -1. And union -1 to positive infinity. Another factoring one here. Let's say part B, f of x is equal to x plus 3 over x squared minus 16. Okay, so we have a fraction, we have a denominator. That denominator cannot be equal to 0. In this case, this is a nice factoring. This is a difference of squares, x plus 4, x minus 4 cannot equal 0. So x plus 4 cannot equal 0. X minus 4 cannot equal 0. X cannot equal -4. X cannot equal positive 4. Number line if you need it. Don't do it if you don't need it. Not equal to, so they're open circles. set notation x such that x is not equal to negative 4 and 4. Interval notation negative infinity to negative 4, union negative 4 to 4, union 4 to infinity. And one more like that. Let's say f of x is equal to x plus 3 divided by x squared plus 16. So our denominator is x squared plus 16. Cannot equal 0. Now this one doesn't factor as far as I can see. So I could use the quadratic equation, but since I don't have an x here, I'm just going to move that 16 over to the other side. It'll become negative 16. And then I will take the square root of both sides. That'll give me a plus or minus square root of negative 16. And what I noticed there is I have a negative underneath that square root. So this is going to be imaginary. And in our class, we will talk about imaginary numbers eventually, but it'll be towards the end of the semester. So for right now, we're just looking for real answers, real number answers here. So because we got imaginary for this, so that means, let's write it out. So there is nothing x cannot equal. So x can be anything. And so since x can be anything, well, set notation answer x such that x is any real number. Interval notation number, so if x can be anything, well, it can be anything you want it to be, anything to the left, anything to the right, that would be negative infinity to infinity.